Alright, so I'm making this video because I've always been very interested in malicious software and how they do all their fun tricks and stuff, because a lot of people, and I would easily say the majority, if not, less than 1%, find what viruses do and how they do it magic. And it's not magic, so it just needs to be put in layman terms. So I just kind of want to take the magic out of viruses and kick them in the face and stuff. So basically, our goal here is to show how a virus would hide itself. This is just one technique of a bajillion. And this would also be used on many other functions. Right now we're only going to use this technique on create file. So anytime you open up a file, the program calls from kernel 32 create file, which opens a handle to the file to let it read and write all the good stuff. So here we got stuff.txt. Oh no, I'm a virus. Grr, I'm gonna eat your face. I'm really not lying, I swear. So that's a pretty serious virus right there. We don't want to run that. We do want to hide it though. So how are we going to hide it? We could just return an error, but that may seem a little fishy. A lot of virus scanners return errors and kind of warn the user that this file was not able to be opened. Test.txt is sweet. So this is going to be our clean sample. Anytime anybody tries to read stuff.txt, we're going to replace it with test.txt. Other techniques, you could actually, patch read file, so that when you're actually reading from the file, you could do it that way. I just figured this way would be easier. So test.txt is a little program that when you run it, it just opens up stuff.txt and reads the stuff from it to the standard output, the screen. So we run it. Oh no, I'm a virus, I'm gonna eat your face. Dang, he ate our face. Just to show that, I'm not making this up. Word. So, for real, I'm totally serial. Alright, so here's OllyDebug. This is the latest, most secret hacker tool ever. Like, seriously? Okay, yeah, it's a debugger. It's got a bunch of cool functions in it. So, alright, we know what function we want to patch, so we want to go to kernel 32 and find this function. So we're going to click, here's kind of a little intro to OllyDebug in case anybody doesn't know. Here's assembly. This is assembly code. It's machine. Here's all the bytes and junk for it. It's actually machine code right there. We're reading. This is exactly what the processor deals with. The processor has a little circuit of it that kind of reads opcodes, which are like call, jump, nop, yada yada yada, and then it redirects the electricity to the little mini circuits inside of it, and that's how a processor works. So here are the CPU registers. They're basically memory inside the processor that's mad fast. Stack we got over here. I think we all know what a stack is. If not, stack of plates, first in, last out. You got to pop stuff off it, put stuff on it. You can't take from the bottom. Well, you can, but whatever. And here's a hex dump. You can have hex, you can have ASCII, you can have signed decimals, yada yada. You can disassemble it. You can make it a PE header. Just kind of another window so you can view junk. So we want to go to memory. This is currently our virtual memory addresses right here. Let's go to kernel 32. We want to go to the code of it. We want to right click in here and go to search for names, which are functions imported or exported. In this case, we are looking for create file. So there it is. This is the very first line of assembly of create file. Our goal is to basically, we want to put a jump here. It's going to jump to our code. Our code's going to run, and then we're going to jump back. So I already know where I want to put my code. It's somewhere down here in all this random empty space that I'm going to make use of. So I already have an address that I want to go to, and it's this. Sweet. Actually, first I want to go to this address, which is just a little bit of, actually I'm not even going to do that, I'll just scroll up. It's right there. So I'm going to right click and say binary edit. This is going to be my string. I'm going to say stuff.txt because we want to look for stuff.txt. Alright, first line of our code. Go there. First line is going to be push AD. because we want to save all the registers on the stack. So all the junk in here, basically before I start messing with it, this is kind of like your scratch pad, while you're coding. Before I mess with it, I want to save everything that's in there because, you know, Kernel 32 probably had some stuff that it was doing, and I don't want to mess with that because it would get kind of pissed off. So next thing I want to do is I want to set ECX to 0. I'm using Xor ECX exclusive OR just because it's smaller code. You know, it's only 2 bytes. I could use move, move ECX 0, but that's a whole ton of bytes, and you know we want to be elite hackers, so let's just do it this way. Oops. Not so elite. Okay, there we go. Next thing I want to do is I want to move the address of where stuff.txt, or where the file that's to be opened is going to be. And, you know, I already know this, but I'll show you how to find this. It's the stack pointer, ESP, plus 24. 24. It's so long away because we're pushing all the stack registers onto there first. You'll see it as we start stepping through this, but you know, you would have had to have found that beforehand to know to put that code in there. So I did mess with this a bunch before making this video. I didn't want to look like an idiot. Alright, next thing we want to do is we want to move the first byte of where that address is pointing to AL. EAX is like that whole deal right there. AL is just those 2 deals right there. AH is those 2 deals right there. And AX is those deals right there. Not really important. Just kind of showing you what AL is. It's not some magic variable I'm pulling out of nowhere. It's actually part of EAX. So, next thing we want to do is we want to compare it. We want to compare AL, which is you know, what we just moved the first byte of the, you know, the string to, and we want to compare that against the first byte of our string plus ECX. ECX starts at 0. Each time we run through this loop, we're going to increase it. So in the beginning, we're just going to be looking at the first byte, which is where we want to look at. Basically, we're going to be increasing each time and we do this loop, and we're going to look at the next letter and the next letter and the next letter. This is basically going to be a very teeny tiny optimized string compare, but written in assembly in you know, like 50 characters, or I forget how much I took it. Whatever. Next thing we want to do is we want to jump if not 0. This is basically going to jump to the address that I tell it to if the... Ooh, I didn't do the compare. It's going to jump if the compare fails. So this is basically like the else statement of our if loop, for loop, whatever. Next thing we want to do is we want to compare AL to 0. Because at the end of the string, you know, strings are null terminated. At the very end, there's going to be a 0. So that lets us know, okay, sweet, we're at the end. If we got this far, we didn't fail. It is, in fact, trying to open up stuff.txt. So, and then we have to put another jump in that case. You know, we say, this time it's jump if equal to, JE. So that's the opposite of jump if not 0 or jump if not equal, whatever. You know, I could have said JZ, it's the same deal. This is basically going to say, this is going to jump to our evil code. It's going to swap the 2 files. The jump before it, if you notice, is just a little bit above it. It's going to, did I do that right? Yeah. Yeah, it's a little bit past it because the way I wrote my function, I didn't want to write 2 functions. I basically wrote it so that the first couple lines are my evil stuff, and then the rest gives control back to Kernel 32. So that way, if I find out that we don't want to run my evil code, we just jump to the middle of the function and it continues on its way. So this is going to jump to our evil code. Sweet. Next thing we want to do is we want to increase ECX. You know, I++ in the for loop. Sweet. And then we want to do a unconditional jump, which basically just jumps us back up to right there, 25. We don't want to do these first 2 loops because we already saved the stack. We don't need to do that, or save the CPU registers to the stack. We don't need to do that again. And we don't need to set ECX to 0 again because, you know, we're using it as a counter. We want to keep track of that. Cool. So next thing we want to do is we want to have our evil string, which is going to live right here. And this is going to be test.txt. Ooh, it's so evil. Alright. Now, we want to write my evil code. My evil code lives at this address. We know so because it jumps there. Right there. So we're going there. There's my evil code. It's not written yet. We have to write it. Evil code, first thing it's going to do is it's going to move the address of test.txt, 43. 42 is the 00, so 43 is the start of that. You can see it. It's kind of weird because Ali's trying to disassemble my strings, so it looks like code when in fact it's not. You know, buffer overflows basically work on the assumption that you can put, you know, code in where text should be and execute it, which you can. So just ignore that for now. That's the string right there. Okay, so we're moving that to there, and cool, Ali sees it. Ali's very smart. Test.txt. Nice. Next thing we want to do is we want to move EAX to where the pointer to the file was. We remember this from up here. We first saved that before we did all our fun stuff. Now we want to overwrite it. So the argument that's passed the create file, we are now overwriting with text.txt. Pretty evil. Next thing we want to do is pop those saved registers that we saved. We want to pop them back to the registers. So now if you notice 5A, this is where the nope, it's not stuff.txt jumps to. So this way we're not blue screening the computer as we run this. You know, that'd be bad. Alright, now if we go up to create file, the jump is, it's going to overwrite a bunch of commands, so we want to keep track of the stuff that it does. Because I've already done this, I know it only overwrites these guys. So basically, before jumping back to here, you know, we can't jump back to here because this is going to be overwritten with our jump to our evil code down there. We have to do these guys, just so that, you know, Kernel 32 doesn't get all pissed off. So, let's go back to our code. Alright, so after the pop AD, we want to do move EDI, which doesn't do anything. I don't know why it wants to do that. Then we want to push the bottom of the stack, and then we want to move the stack pointer to the bottom of the stack. This is basically opening up a new frame for it. You know, every time you call a new function, you have local variables as opposed to global. So this is where you're getting that new scratch pad or whatever you want to call it. Then we want to jump back up to this address. I get this address because I know that it's going to be right there. So that's where we want to jump to after we're done our stuff. So let's do that. Now, our code starts here. This address. We want to go up to Kernel 32, the create file function, and we're going to overwrite the first couple commands with the jump to our code. So when you call create file, first thing it's going to do is it's going to go to our code and then run our code, and then it's going to jump back to where it should be. So this shouldn't kill the computer. I hope it doesn't, because I don't really feel like restarting it right now. Just in case, what I'm going to do, and so you guys can see how this all works, I'm going to set a breakpoint. Breakpoint is basically, I don't want to get into the nitty-gritty of how it works, but it's basically going to pause the program when it gets to this address. So, okay, so we are now at my address. Jump, okay, so we're starting to call our code. You see all the CPU registers over there. This is our current address, the EIP. There's our stuff. Oh, stuff.txt. It tried to open stuff.txt. So, it should, we're going to watch this work line by line. So I'll kind of give a commentary. First, pops all the CPU registers onto the stack. You notice this used to be up there. all that junk is from all up here. So it's saving all that stuff. Next, it's setting ECX to 0. ECX right now is B, so you should see a change. But it changed. Sweet. Next thing it's going to do is it's going to move. You can see right here, Ollie kind of like looks ahead and see what the stuff is. This is how I knew that it was ESP plus 24. I saw this was here. The ESP is right there. And then if you do 84 minus 60 in hex, you get 24. So I did ESP 20 plus 24. It pointed to the right thing. Sweet. So now it's moving this address to there. Bang. So that worked. Now we want to move the first byte of where that address is pointing to AL. So it sees that the first byte of where it's pointing to is S, stuff.txt. So AL right now is 0. AL is this little byte right there. Boom, it changed. Ignore what this is saying. This is not pointing to where we're doing. Ollie tries to make a lot of stuff easier for you, but I mean, when you get a little bit more hardcore into taking stuff apart, some of its functions aren't real useful, but it's real customizable, so whatever. So now we got S in there, and we're comparing S to the first byte of my string up there, which is an S. 73, 73, sweet. So jump is not taken because it was the same. Good. Now we're comparing it against 0. Are we at the end? Nope, it's still S. Jump is not taken. So we add 1 to ECX. It was 0, now it's 1, and we jump back to the top. Because we messed with the AX, I have to reset it. If I wanted to optimize this a little bit more, I probably could have used a different register. Don't really feel like recoding it right now. I think that's a pretty tight string compare right there. So we set that back to what it was, stuff.txt, then we move the byte again. Now it's a T. Okay, cool. Now we're comparing T to T. That's good. Alright. So not taken. Is T 0? Nope. It's T. Keep going. Alright. Now it's U. Cool. We're reading stuff. U to U. That's good. Is it 0? Nope. Let's go around again. F. Cool. Is it 0? Nope. Round again. F. It's the same. Cool. Is it 0? Nope. Go around again. Dot. Dot. Sweet. Is it 0? Nope. T. Cool. X. Cool. T. Cool. Okay. Now it's going to be 0. So it moves 0 to AL, which it already is. Not a big change. Compares 0 to 0. The end of my thing is 0, so it's comparing right there. That's good, because we want it to do that. Jump is not taken. Now it's comparing it to 0, which it is in this case. So jump is taken. Now it's going to jump to my evil code, because, it didn't hit this jump before. If it had failed this compare, it would have jumped to right there, and it would have done my 2 little lines of evil code. But it's going to jump to my 2 little lines of evil code, so let's let it. Boom. Jump to my evil code. So it's replacing stuff with text. Let's watch it. Oh, no. Oh, man, that was a letdown. First thing it does is it puts test.txt into EAX, which it has. Stuff.txt was at EAX, so I got a little confused. Now it's going to move it down there. Boom. Whew. Okay. Popping the stack registers back off. This should move back up. Boom. All right, we're moving EDI to EDI, which does absolutely nothing, but since the kernel did it, I'm going to assume that it knew what it's doing. All right, we're pushing the bottom of the stack pointer. Boom, there's the bottom of the stack. We're moving the bottom of the stack to the stack pointer, and now we're going to jump back to where the kernel left off. I'm going to press run at this point because I don't feel like stepping through all the rest of kernel 32. Let's hope the computer doesn't blue screen, and let's hope it reads out sweet. Okay, so it's running. Sweet. It ran. We just patched kernel 32 to open up test.txt whenever it sees stuff.txt. Okay, I didn't like that. That's... Okay, well, at least nothing blue screened. I don't know what that was. Oh, okay, that was Ollie. So if you guys have any questions, just email me or, yeah. If you guys want to see anything else taken apart or any other rootkit techniques, there's a whole ton of other fun stuff. Yeah, I guess that's it.